Hi guys, in today's video we are going to focus on how we can solve for x if we are involving logs, right? So now before we can dive into solving the question, let us first revise our log laws because it's very important that you understand them and that you remember them, because if you do not, then it becomes very difficult for you to actually solve for x, or sometimes if you're asked to simplify for x, right? So now let us first look at our log laws. Now these are our log laws. So the first one is log a base x plus log b base x is equal to log ab base x, and log a base x minus log b base x is equal to log a over b base x. So now on these first two logs, right, I need you to understand something. These two laws are only applicable if the bases are the same and if your log terms are different from each other. That's the only time that you can apply this. Now, what do I mean by this? Let me show you an example, right? Now, let us say that we have, okay, let's say we have log, right? Let's say we have log 2x plus log 2x. Now, if you have something like this, you cannot use any of the two first laws. Why? Despite the bases being the same, the problem is the two terms. They are the same. Therefore, we cannot use the law. We can only use the law if these two are different from each other. That's why we say that it's A and B. So now this means that this would be an addition or a subtraction of like terms, but since it's an addition, it's an addition of like terms. So this would actually give you a 2 log 2 base x. That's what this would give you. So it's very important that you understand that the only way for you to actually use these first two laws is that these two must be different from each other and the basis must be the same. Now let us look at the next one. So you have log a exponent k base of a is equal to k log a base of a. So now if your log term is exactly the same as your base, it's equivalent to 1. See these two, right? So basically this is the same as this. That's why we only have k here. So if your log term is the same as your base, then it's 1, same as what we have here. So now log of 1 base 8, it's equal to 0. So now it does not matter what your base is, so long as your log term is equivalent to 1, then it's equal to 0, right? So now let us look at the last one. So log a base b is equal to log a divided by log b, right? Okay, now let us try to solve for x by applying this rule in an expression, right? Now let us first look at this one, right? So we are asked to solve for x. What's the first thing that we need to do, right? Okay, now the first thing that I need us to do, I need us to simplify this part, right? So now this would mean that we have log x over log b, it's equal to 3 log 5b, right? The next step that I need you to do is to multiply both sides by this. Why do I want us to do this? Because I'm trying to have only the log values or terms on the left, and then so that I can only have only 3 on the right. Now this gives me an edge because I'm able to simplify my expression further without having it to be like complicated and all. Right, so now from this, I'm multiplying both sides, right? Multiplying both sides by log 5b, okay, by log b5, right? So this would be log b base 5 times log x divided by log b, it's equal to 3, right? So now from here, what you can do you see that we can convert this part, right? We can convert this part and say that it's log b, it's over log 5 times log x, it's equal to 3 divided by log b, right? Right. So now from here, we need to introduce a base, right? That would make our equation to be less complicated, or so as to say it must be true, right? So you can choose to use any. You can use b, you can use 5, you can use x. It's all up to you, so long as it does not make your whole expression to be a bit complicated, right? So now on this expression, I choose to use 5 because I'm trying to get rid of this uh, fraction over here. So 5, 5, 5, and 5. So this would be 1. Remember, a log of 5, base of 5, right? So the log value and the base are the same, therefore it's equivalent to 1. So now this means that you have log b5 times log x5, it's divided by log b5, it's equal to 3. So now the bases are the same on all of them, right? And if you look closely at this, these two terms are different from each other, right? And if we are considering this one, we can subtract it, right? So we can say that it's log b5 plus log x5 minus log b5 is equal to 3, right? It's equal to 3. So now from here, if we look closely at these two, right, they are common, right? Yes, they are common, this one. So we can cancel them out. So now this means that we only left with log x5 is equal to 3, right? So now we need to convert this from a log form to an exponential form, right? So let's say, for example, you have log b x is equal to a, right? So you're trying to convert this from a log form to an exponential form. So what you would do is the base does not change. The base will always remain the base, but the equated term becomes the exponent. So now this means that this would become xa is equal to b. Now you've converted the whole expression from a log form to an exponential form. So you can go back to a log, or you can go back to an exponential form. So if you're converting this from a log form, from exponential to a log, remember our base remains the base and our equated term becomes the log term. So this would mean that you have log b x is equal to a. So this is how you can convert back and forth from expo to log, or from log to expo, right? So now this means that from here, our base is this, and our equated term is this. So now this means that our exponent is this. This is our base. So x is equal to 5 cubed. So this is our final answer. So you see, it's very important that you understand the laws. It's very important that you remember how to apply them. Now let us look at another question, right? Let us look at another question. Let's say that we have a log of 3x is equal to 4. Now if we're trying to convert this, right, remember the base would remain the base, the equated term becomes an exponent. So now this would mean that you'd have x is equal to 34, right? It's very simple. Let us look at another example. Now we have log 2x squared minus 2x, right? It's equal to 3. Our base remains the base, right? Our equated term becomes the exponent. So now this would mean that you have x squared minus 2x is equal to 8. So now x squared minus 2x minus 8 is equal to 0. Then now you can factorize this. So it's x, since they're both negative, it's negative 4. And x plus 2 is equal to 0. Now x is equal to 4. Or x is equal to negative 2. So that's basically how you can solve for x in a question like this one, right? Now let us look at another similar question. Now let's say that you have log 4x minus 6 plus log 4x, it's equal to 2. Now if you look closely at this, these two are the same, right? They are the same, and these two are different from each other. Therefore, we can apply the law that says that if you are adding two logs that have the same base but with different terms, we can multiply the terms. So we can say that it's log x minus 6, it's equal to 2. Let us write our 4. Right, so now let us convert this from a log to an exponential form. So now this would mean that we have x minus 6, it's equal to 4 squared, right? X squared minus 6, x, it's equal to 16, right? So now from here, x squared minus 6x minus 16, it's equal to 0. Now we can factorize this, right, and say that it's negative 8 and x plus 2. Then x, it's equal to 8, or x, it's equal to negative 2. So you see, the only way that you can be able to actually solve for x when we are involving logs is for you to understand how to apply the laws. It's for you to remember the laws, because if you do not remember them and if you do not know how to use them, then you practically have a problem. You understand? So let us look at our final question. Let us say that you have log 5x plus log 5x cubed plus log 5x5, it's equal to 18. Right, so now from here, right, if you look closely at this, the bases are the same, right? So since the bases are the same, we need to look at our terms. Look at this, we have x cubed, and we have x to the power 5, right? So now since they are all different, we can apply our law, right, and say it's log 5x times x cubed times x to the power 5, it's equal to 18, right? So now from here we can say that it's log x 1 plus 3 plus 5, it's equal to 18. The reason why we're doing this is because these bases are the same, therefore we can add the exponents, right? So now this would mean that it's log 5x, that's 5 plus 3 plus 1, that's 9, it's equal to 18. Now from here, the only way that we can actually solve this, we need to get rid of this, right? Sorry about that. So what we're going to do is 9 log 5x, it's equal to 18. So basically here we're just using this law that says that it's log, if you have a log of ak, it's equivalent to k log a. So this is the law that we're using to simplify this, right? So now we're dividing both sides by 9, right? So these will cancel out. So now you have a log of 5x, it's equal to 2, right? So now from here, we need to convert from an exponential form to, from a log form to an exponential form. The base would remain the base. Our equated term becomes our exponent. So now this would mean that our final answer is x, it's equal to 5 squared. So basically this is how you can solve for x if we are involving logs. Just remember that you need to understand your log laws, and you need to understand how to use them and the things that you must avoid. Just try to avoid using the law if you have the same base and the same log terms. That's the only time that you cannot use the first two log laws. You understand? So if you have any question about solving for x involving logs, please hit the comment section and let me know. I will explain to you. Thank you for watching the video. Please do subscribe to my channel for more videos. Cheers.